Welcome everyone. Good morning from Nigeria. Okay, my name is Samuel Nwoye, and I want to thank you all for joining, for the ones that have joined from Nigeria and the ones still yet to join. I like to call myself a development productivity engineer. You see, these days, DevOps is about a lot of things, and somehow it's become a buzzword. And most times you speak and they were like, oh, no such thing. Those are all pranks or some of those marketing terms. So today my talk will be specifically demoing a fictitious implementation of DevOps for a particular CEO by a consulting company. So I tried as much to see that this sort of a little bit looks or paints some reality to how DevOps really works. Now, I'll have to point that it is different with different companies, and the tools used are also different based on the company. So basically, it's just an eye into the reality of DevOps. That's what this talk essentially is gonna be today. Thank you once again for all joining the session. So let me begin by showing this. Okay, can you all see my screen, please?
Yes.
We see you, Samuel.
Okay, so let's go here. This is my slide, and that's the title of my talk. So a brief explanation of the architecture of this particular infrastructure for the CEO's homepage application. I will be using AWS as the platform for demoing this, and a quick look into what will be housed in our infrastructure. So, and how the flow of traffic would happen. So if a user hits our Route 53, which is our domain service for AWS, it takes the user's traffic through the AWS VPC flow log so that I'm able to register, or we are able to register what happens in our network. And then we also made sure to have an AWS config trail so that developers' API access and or whatnot can be tracked so that we know who did what was done and when. And then essentially, because every good DevOps engineer should be looking at having a visibility into the infrastructure of whichever company they are managing. Whichever platform you use, I believe they do have these things. Now, the AWS config is for looking into what is running, where we can optimize things, what is probably redundant, and what we need to remove. Because once you keep doing these things, you are actually you're making an action that sometimes are not automatically removed. Some things like EBS volumes, unless you actually specifically said that the EBS volume should be deleted with the instance when the instance is deleted. So AWS config helps us to look at the things that are in our infrastructures and how they are running, which has which relationships to which, and stuff like that. I will also leverage on the AWS S3 bucket and the DynamoDB. Essentially, those two are for my storage. And because I'm applying or implementing the remote state backend of Terraform, I had to call on AWS S3 and DynamoDB for my lock and then storage of my state file. Now let's look into the system itself. Now, you can see I have two availability zones here, right? They are both public, but for real clients, depending on what they have asked, this is not essentially what I do or what is advisable. It's not a best practice, just for the demo. Now you have just one instance of the application where the application will be running, and then another instance where we have all our other services like Jenkins, Prometheus, Grafana, all that we know that is part of what will make our work a wholesome DevOps process. Next is look into how the flow of things happen after we've stood the application. So here is our engineering team talking to the GitHub repository. And then from the GitHub repository, at push, a Jenkins pipeline is triggered. And then the Jenkins pipeline calls a Packer definition. Oh, Packer is actually an awesome tool that makes orchestration of your server instances very easy. Now, naturally, or previous to this whole DevOps movement, operation engineers more like have to go through their own books or even go through dozens of bookmarks for them to configure a particular server. Now, what automation preaches is have this thing documented, have this thing written just like the coders or the developers write their code. And by the way, operators also test just like the developers test. We'll be seeing all that today. So I will be using Packer and Ansible to orchestrate an AMI machine. This AMI machine will be containing both the applications, like the software dependencies that we will need for the application to run, and the application itself after developers have developed it. Now on core, after this, we'll move that AMI into a Terraform file where it is now spawned up as an instance itself. Now, this instance has a relationship to Prometheus. By the way, I need to explain a little bit of stuff here. What this flow means is that this Terraform can kickstart another Jenkins file to deploy to staging, and if it is okay, or when a user certifies that we are fine with what we have seen after the QA guys, the user testers, user and experience testers have looked through the application, we move to production. Now, the Prometheus and Grafana symbol here is like monitoring the entire infrastructure, monitoring everything we have deployed, from our EC2 instances to whatever you have in that infrastructure, as long as you pointed it to be monitored by Prometheus. Okay, thank you all. So, just like I said, what is DevOps? It's a software development and delivery methodology that combines cultural and operational paradigm in achieving business goals. So essentially, it's developers and operators working together without any of the parties blaming one another for errors. Like, we have trust that, hey, this guy is working. This guy is working for me as well as I'm working for him. We are seeing that this particular business goal is actualized without either of us pointing fingers at one another. So normally what happens when you begin a project is that the client comes to you, define whatever it is they want, agreements are signed and mobilization is done, kickoff process begins. Now, the real thing happens in the engineering team. The engineering team sits down, defines this particular requirement that have been gathered as task, break them down to be reasonable, translate those requirements technically. Okay, this is how we think this should be, this is what this particular thing would look like. And then put them out as cards and weigh what that particular task would take in time. So if we have a task A saying develop a login page, right? A login button that the users can enter their password and their username to take them to the index page, or rather to take them to the dashboard page, whichever way the flow is. This particular part is estimated how long it will take for the developer to develop it. Then what we call poker estimation is done to bring to reality the average amount of time this should take. So now, after the team has actually done their thing, usually the first guys that get to work is the ops team, based on what they have understood from the discussion they had in the engineering team. Now, what the ops team does is create the repositories and the team members for each repository. We are trying to save costs here. We don't want to run our development machine on the cloud. And again, we want our development machines to be in parity with the production machine. We define a vagrant file, then describe configurations for that particular machine we'll be using Ansible. You could use Chef, Puppet, whichever one, but for this demo, I will be using Ansible. Then test and provision the machine. So what essentially this means is that right from the word go, we are testing and we are deploying. We are testing and we are deploying. Even as basic as provisioning the development machine for the developers, the operator or the operations team have to also test that the machine is configured appropriately using server spec. Then you will now push this to the version control system, which GitHub in this case will be what I'll do. So here's just a sample code of the Terraform file the operation engineer runs. Provision, GitHub, the name, blah, blah, blah. And here's a sample code of what our vagrant file will look like. Okay, before this, let's just do a bit of demo. Here we go. So I have my vagrant file here. The vagrant file describes the VM I'll be running. Then here in the configuration page, I have the rules, what I will be installing, the Go app, the Golang binary, ng's, node exporter, because DevOps preaches CAMS. That's these 4 pillars of DevOps: culture, automation, measurement, and sharing. We have to be monitoring, have to be measuring everything in our system. Okay. So, but before then, let's since we've had our engineering meeting, let's do a quick one of provisioning our repositories. Let's just do a show of that here. So if you take a look here, I've already done that. Right? And I didn't do this by hand. I'm just showing it because I don't want to kill the time. You can see the team. We have the cloud team, we have the dev team, we have the ops team. Unfortunately, because this is a demo, I didn't get anybody to collaborate with me. But what this simply means is that if anybody is part of this organization, we can simply get them on board without going through this interface. All I need to do is, as maybe the ops lead, just get on this here. Let's show it. Just get on this here and provision or add the user, whoever the user is. Just add the user. So you can see developer users, operator users, just like that. That was defined in our Terraform code. Now there's another essential thing I needed to show, and that is vaults. So interestingly, because we will be dealing with a lot of secrets, right? At the beginning of every project, usually this is done online. A vault is deployed. You can check out some of my Ansible rules for automatically deploying vault with a KMS key, because up there you rather do auto unseal than go through the process of manually unsealing your vote instance. So what vote does is to keep our secrets. Whatever we did not find something that we need to put in config files and things like that, whatever we think is personal to people, they can just keep it there. Now, if someone is part of the company, they can just authenticate. Being part of the company will get them, we configure them to be part of this, to be able to have access to vote. And the administrator of vote is actually, or the security guys are actually the guys that take care of this. And then the person can easily get their secrets or any credentials that they need for their day-to-day operations. Okay, so that is that. And assuming we've provisioned our GitHub, next thing is for us to deploy the Vagrant file. I'm not sure I want to run this. Please forgive me, guys, because it sort of slows the system. So let me just do a basic show of what would happen using my local though. So I just want to show us a bear. Just the best of this. So this is just a simple Go app application. I just run this. So I'm assuming this is the developer doing his thing, right? And once he's done, you can check out what he just did. There you go. Okay, there you go. Yeah. Oh, it's taking quite a time. Okay, it started. So basically, this is the beginning of the stuff. Now, if the developer commits that code, a Jenkins process is spawned up. So let's assume this. Oh, really? Okay, cool. Since I modified stuff, okay. Now this kickstarts this stuff. Now what this does essentially is take us through the flow, you know, the run, the build stage, and push back our binary into our repository. The Jenkins process is supposed to have been started. Okay. All right. For some reason, I don't know why. let's just build this by hand so that we'll see. Oh, something is not right in our Jenkins file. So let's take a look. Something is not right. Okay. So basically, good. Okay, now it's all right. I'll have to skip this. I don't know what's wrong with it. The gods of demo are probably unhappy with me. So, oh, sorry. I was doing something else. So this is what I was actually looking to run, because this is for the code. This is for the code. Yeah. This is for the code. That is for the AMI. So when, okay, it's still failing. Whatever. But basically, once the developer pushes their code, a Jenkins pipeline is kickstarted, tests the project, builds the project, and submits the binary back to the repository. Here is just to look into the flow. Yeah. That's just it. That's just it. Then calls our build AMI job, so that if that was successful and when it's master, we don't want to be building development. Let it just build, drop, but don't build an AMI just for development. Now, if probably some set of reviewers and seniors have certified that, okay, on pull request, that particular pull request did not break anything and is committed to master, the next, another pipeline is started and this particular stage runs, calling this AMI build job, so that it will now create our template for us. Now, like I said, we have to be monitoring everything. Here is a Prometheus. This was also automatically installed. Here's a Prometheus system that monitors all we do, what happens in our infrastructure. So at the moment, I have just 2 instances. If I had spun up the other instance, we would have seen it here, but this is just a look. Now, because we are also measuring things, I have a Slack channel where my Prometheus sends alerts on situations of things, where we can see where my Jenkins build, whether it failed or succeed, are reported. These are all that happened previously. With this, I have an eye into what is happening. You could also define an email approach where this is sent to an email address or the person in charge or the person in question that built this particular build pipeline. So I think I will have to stop here for not feeding into others' time. Yeah, I think that's it. Let's stop here. So I want to take the questions now, please.
Yeah, that was really cool, Samuel. Everybody suffers the fate of those demo demons every now and again. It's the unavoidable, but very, very brave of you for doing the live demo, and everybody, I'm positive, appreciates it. if anybody does have any questions, we've got a couple of minutes. I'm going to kind of ask a question while we're waiting for some stuff to come in from the stream. But how long have you been working and operating in this manner, Samuel? And kind of what is it that's so appealing for you?
This is about 2 years. Of all the stack I demoed or showcased here, the only one that I've not been accepted by the people I've worked for is Volt. And I understand, I quite understand why. There is this fear about, wow, why would we have to manage our secrets in just one server? What if this happens, if that happens? But I'm hoping that probably the next client I'll work with will want to take on this, because Volt is awesome. In fact, just to show us the awesomeness of Volt, this is actually our secret engine. Everybody, the employee's secret and the access they have to which or whatever is defined. So maybe the CTO, the CEO can just take a look and see, oh, okay, this is the access this group of people have. This is the access this group of people have. And when somebody leaves the company, it's just a question of removing them from here, and every other places like our AWS infrastructures and whatever, they automatically cease to have access to it too. Quite awesome. Now let me also show this, because there are a lot of things you could do. Why this is cool, right? You could choose to use user pass, which has already been configured. I think I did that somewhere. Yeah. You could choose to use a number of authentication methods, and you could use auth. So if somebody wants, probably, yes, they are part of our organization now, they could sign in to Volt with their GitHub account. Very easy. So this is just the only guy that a lot of people have been having issues to accept. But Terraform, Packer, Vagrant, awesome. I think it's something they are comfortable with. Volt, because it's a secret management. There's this.
That's awesome. I'm kind of a slightly biased fan. Slightly biased, but I am a fan. I was a fan always. That was a wonderful presentation, Samuel. I genuinely want to send my heartfelt thanks to you. That was absolutely fantastic.